Designing pumps which meet the wide range of industry applications and standards can be very challenging if you don't have the right tools to support your design process. As I'm sure you know, cavitation is to a pump what a wooden stake is to a vampire, and parameters like efficiency take second priority for the selection among designs able to reach the desired discharge conditions in the absence of cavitation. It is therefore critical to determine key parameters such as suction cavitation performance at the beginning of the design process so that development costs can be reduced and pump performance can be optimized. In the example shown, we can see how using AxSTREAM's preliminary design inverse solver we are able to generate very quickly 5,000 different centrifugal pump designs from scratch for a range of input data and then review their performance in the Design Space Explorer. Each dot in the design space corresponds to a different geometry, and we can then review the influence of each of the input on the desired output. From there, user can filter and sort their designs based on various performance, including cavitation, as we can see here, manufacturability, and so on, in order to select the optimal design for their case. New geometries can be added to the scatter plot in order to investigate new values of input data, such as different rotational speeds. Which I could actually have set up from the beginning to be used as a range instead of fixed values. Here, however, it is interesting to see the two different families of rotational speeds, one here and the other one over there, and how their relation to efficiency on the vertical axis and cavitation on the x-axis is going to differ, since the impeller speed is going to affect the minimum inlet pressure required to avoid cavitation. Design candidates with a value lower than 0 here are going to be subjected to cavitation, so all of the ones here with the higher rotational speed. The ones over there are, however, going to be cavitation free at the design point, and the higher the value, the more cavitation resistance they're going to have. The idea of this module here is going to be for us to determine which of these designs or others we want to select for the detailed design process and the analysis. So we'll just select one of them here. We can then review its 3D geometry in this window here. We can run some 1D, 2D calculation, as it can be done here very easily, to study the performance of this machine, investigate the different losses in order to optimize the geometry, and so on. And this module can actually be used also in order to create performance maps, like the one that we're going to see right here, where we are investigating for different values of volume flow rate what the head is going to be at different rotational speeds. So these are going to be the different curves that are going to be on here. In the same way, we could look, for example, at the same parameter that we just looked at in the preliminary design, where we're going to have the cavitation suction left. And the idea of all of this is just to make sure that the pump is going to operate cavitation free for all the different operating conditions. And from there we can finalize the design with the blade profiler. We can then pass the design to 3D analysis tools, which could be, for example, AxSTREAM, AxCFD, or even export the geometry to some other external software.